Right now, as you watch this, trillions of ghost particles are passing through your body every single second. You feel absolutely nothing. They glide through atoms, through walls, through the entire Earth itself, as if it weren't even there. These are neutrinos, the most elusive particles in the universe. Nearly massless, traveling at almost the speed of light, they are born in the fiery hearts of stars, in cataclysmic supernova explosions, at around monstrous black holes billions of light years away. To catch even one of these ghosts, scientists had to go to the most remote and extreme place on our planet, the South Pole. Beneath the breathtaking starry sky in Antarctica, buried a mile deep in ancient ice, lies IceCube, the world's largest and most extraordinary telescope. It's not looking up at the heavens, it's looking straight through the Earth to see the invisible universe. Constructing IceCube was one of the greatest engineering challenges humanity has ever undertaken. In temperatures plunging to minus 50 degrees Celsius, in one of the harshest environments on Earth, teams of scientists and engineers drilled 86 massive holes, each more than 2.5 kilometers deep, straight down into the Antarctic ice sheet. Using jets of hot water, they melted perfect vertical tunnels through ice that has remained untouched for hundreds of thousands of years. Then, string by string, they carefully lowered thousands of highly sensitive light detectors called digital optical modules into the frozen depths. These basketball-sized spheres, over 5,000 of them in total, now form a vast cubic kilometer grid, the largest neutrino detector ever built. The ice itself is the key. It's the clearest, purest natural substance on the planet, allowing faint flashes of light to travel hundreds of meters undisturbed. IceCube transformed frozen water into the ultimate telescope for seeing particles that ordinary light telescopes can never detect. The digital optical modules capture fleeting blue flashes of light that randomly occur when neutrinos interact with ice atoms, recording the exact timing and intensity with nanosecond precision. By analyzing the pattern of light across the entire grid, scientists reconstruct the neutrino's path, energy, and even the direction it came from, often tracing it back across billions of light years to its violent cosmic birthplace. IceCube has already changed everything we know about the universe. It has detected high-energy neutrinos streaming from distant blazars, supermassive black holes devouring matter at the edges of the cosmos, and even mapped our own Milky Way galaxy in ghostly particle light for the very first time. What else will these mysterious particles reveal?
Thank you for watching. Please subscribe to the Off the Chart Multimedia YouTube channel for more fascinating videos.